An intensive testing phase for our products is particularly important in order to be able to test our future products in their real field of application. My name is Daniel Sauerteig. I'm part of the product development team here at STIHL, responsible for the system development of our battery packs and chargers. In the AP500S battery, we're using the power laminate technology as a new cell technology for the first time. The battery pack is also very robust and designed for a high power draw for our professional customers. With this technology, the individual electrode layers of a lithium-ion cell are stacked on top of each other, allowing us to optimally utilize the volume in the cell and the volume in the battery itself due to the shape of the cell. The increase in performance of the AP500S is approximately 30%, which is mainly due to the cell technology. When we develop a new battery pack, we plan intensive trial and test phases. When we check and test our battery packs, what counts first and foremost is, of course, their performance in our applications. This involves temperature tests, extensive safety tests, and mechanical tests. During a test with a partial freezer, we cool the system down to its minimum operating temperature, ensuring that the system is ready to start and work even at these very low temperatures. Testing also takes place in an application-related environment, for example, in a sawing application, in order to continually improve the product and get it ready for series production. A very good example of a mechanical load test is our drum test. In the drum test, the battery pack is subjected to mechanical shocks, impacts, and vibrations. This enables us to identify any weak points in the mechanical structure and design and to take appropriate measures to resolve them. The vision for the future is, of course, to offer customers more features. This includes, for example, extended power release and even more charging options on the one hand. And on the other hand, there is also a focus on durability and sustainability. We can achieve this through connectivity by adapting and optimizing the behavior of the battery pack to real-life use.